Hi everyone, in this video I'm going to talk about the two-pointer technique, which is a processing technique used on sorted arrays. I'm going to illustrate the technique using the merge function in mergesort and toSum, the popular LeetCode problem. Both of these problems often show up in technical interviews. The two-pointer technique involves the use of two or more variables, which we call pointers, to keep track of the location or the index place of elements of interest within the same array or of two different arrays. So this technique is often used with sorted lists, symmetrical lists, or strings. The first example we're going to look at is the merge function in mergesort. So if you're not familiar with mergesort is one of our fastest sorting algorithms with a runtime of O of n log n. It's a divide and conquer algorithm that takes an unsorted array and breaks it in half. It recursively sorts the two halves using the merge function, and then finally merges the two sorted halves into one combined sorted array. Okay, so let's take a look at the merge function in mergesort. The problem is we are going to merge two sorted arrays into one sorted array. So first we'll go over the approach, and then we'll look at some slides that illustrate what's happening. So the approach is we are going to use two pointers, or variables I and j. Each will start at the beginning of each array. Then we are going to compare the elements and add the smaller element to the new array. We'll then move the pointer of the array with the smaller element and continue the comparisons. We do this until one of the arrays is exhausted. Then we'll copy the remaining sorted elements for the other array to the final array. Okay, so let's look at an illustration of this. Okay, so here we are, we're starting with our two sorted arrays, and the goal is we want to create this larger array with those two sorted arrays combined in it. So the first step is we have I set at the beginning of the first array and j at the beginning of the second array. We're going to compare those elements and add the smaller to our new array. And then we increment I. So now we're going to continue comparing the elements at I and j, and we're going to add the smaller. So in this case, we add 3 to the new array, and we'll increment j. Now we compare 6 and 5. So we're going to add the 5 and increment j. Now we'll compare 6 and 7. We'll add 6 and we'll increment I. Now we compare 10 and 7. We add 7 and increment j. Now we compare 10 and 8. We add 8. And now our second sorted array is exhausted. So the last thing that we have to do is we're going to add the remaining elements from the first array to our new larger combined array, and then we're done. So that is the merge function using mergesort. So it does often show up in technical interviews, but your interviewer probably won't ask you for the merge function of mergesort. They'll probably ask you if you're given two sorted arrays and need to combine them into one, how would you do it? And this is how you would do it using the two-pointer technique. The next example is toSum in a sorted array. So the problem wants you to find two numbers in an array that sum to a target approach, or that sum to a target value. Let's take a look at the approach. You're going to use two pointers. You're going to have a left pointer that starts at the beginning of the array and a right pointer that starts at the end of the array. You're going to calculate the sum of the element at your left pointer plus the element at your right pointer. If the sum equals the target, you found your two numbers that sum to the value and you return that pair. If the sum is too small, then you're going to move your left pointer forward and continue. If the sum is too large, you're going to move your right pointer backwards and continue. So I have some slides that illustrate this. Let's take a look at them. So our problem, we want to find two numbers in the list that sum to a target. So let's say in our example, our target is 10. So we're going to put our left pointer at the beginning of the array and our right pointer at the end of the array. So we're going to sum those numbers. So 1 plus 11 is 12. Our target is 10. So 12 is greater than the target. So we're going to decrement the right pointer. Okay, so why do we do that? If we incremented the left pointer, the sum would be even higher since the list is sorted. We want to reduce the sum, and the only way to do that is to try a number less than the number at the end of the array. Okay, so 12 is greater than our target. We're going to decrement the right pointer. Okay, so we decrement the right pointer, and we continue to add our numbers. So 1 plus 8 is 9. So now we're less than our target, so we're going to increment our pointer on the left to try to increase our sum. Okay, so now 3 plus 8 is 11. We're over our target again, so we're going to decrement the right pointer. We decrement the right pointer. 3 plus 6 is 9. So we have to increment our sum, so we're going to increment the left pointer. Okay, so now 4 plus 6, we've reached our target. Our target has been found. So one thing to note about this two-sum problem is that the two-pointer technique only works on two-sum in a sorted list. So there's another very popular interview question that asks you to find the sum of two numbers that target to a number in an unordered list or an unsorted list. You cannot use the technique on an unsorted list. So you can think about how to solve that. One approach would be to sort the list and then use this technique. But if they're asking for the index place of the numbers, you're not going to be able to do that. So a common way to solve it is to store your numbers and the index place in a dictionary. Okay, so that's how you would solve it in an unsorted list. So for this week's problem set, I give you both of those problems, two-sum in a sorted list, two-sum in an unsorted list to get some good practice. Okay, so check out the problem set for this week. Have fun with it, and good luck.